All right, so I'm going to quickly go over this SEAL team project for you guys because I think there might have been a lot of questions that you guys are having. So basically, when you're solving for these, all you're solving for is the time that it takes each SEAL team member to get to that spot, their spot of the where the truck's going to pass by. So you're solving for time in all of these. I know it says to determine the 4 locations. Location, I think when we come back from the break, we're going to be doing more with the location part. Right now, you just need to know how long it's going to take each one to from their starting point to get to their like entry point into the truck. So time for all of these. All right, so if you go down and read the additional intelligence part, that's where you're going to get your information on the numbers that you're going to need to use. So for SEAL number 1, he's sprinting across a 2.44 meter stretch. Level ground, he only has one velocity. So that means he has no acceleration. Well, when I'm looking at my formulas over here, the only one without acceleration is the top 2 formulas, and really the v equals x over t is all you need to use here. So that is how you're going to solve for time in that one. SEAL number 2, it says that he is going to maintain constant acceleration. Constant just means his acceleration is not changing. So here we know he does have an acceleration, and it gives it to us right here, the 0.335. So A is going to be that number. And then it gives us a distance that he goes. Don't worry about the 5%. That's just telling us that he is going to accelerate because he's going down an incline. You don't need to use that in your math problem. And it's 2.44 meters that he goes. He starts with an initial velocity of 0 because he starts from rest as he goes. And you want to solve for time. So looking at these, I can then choose my position time equation, and I can cut out a lot of that equation because everything starts from rest, starts from 0. So I'm going to cut right to that equation right there to solve for t. SEAL number 3, he went over a little bit, I believe, in one of the classes. I don't know if he went over it in all of them, but in SEAL number 3, you have to use the graph to understand what he's doing. And so basically it says that we have information up to 2.75 seconds, but beyond that, we don't know how long he went. So from 0 to here, the 2.25, he had an acceleration. Okay, so he was changing his speed. Well, from 2.25 to 2.75, he was at a constant velocity of the 1.8. Okay, so right here, he was going 1.8 meters per second for 0.5 seconds. So from, 2.75 minus 2.25 is 0.5. All right, so from that information right there, I can use, since there's no acceleration, I can use this formula to solve for the distance that he went. So 1.8 equals x over 0.5. That distance is 0.9 meters. Okay, from this section right here, he went 0.9 meters. Well, if you read up here, it says we know that he traveled an additional 0.9. So he went another 0.9. Well, if there's no acceleration and nothing changed, then I know that he went another 0.5 seconds because here he went 0.9, here he went 0.9, nothing changed, and so these two things have to be the same as well. The time has to be the same. So his total time, well, here he went 2.25 during that section, and then he went another 0.5 during that section, and then he went another 0.5 during that section. So you should be able to get his total time from all of that. So hopefully that helps. And then, excuse me, SEAL number 4 is a free fall. Excuse me. Free fall because he's dropping down. You have a distance of 2 meters. You know that acceleration when something drops is gravity. He started from rest, and then you can solve for time. So I would choose that formula to solve for t. Good luck.